Okay, let's look at some really specific quadratics that you might come encounter with. And so I had said in a previous video that one of the reasons quadratics take so much more time to solve is because you have two different terms with x's. You have an x squared term and you have an x term. And so it's difficult to isolate that x term. So we use methods such as factoring or we've got some other methods as well. To help kind of break those X's apart. Okay. Um, and so with these today, we're going to see something very specific. These equations are not going to have any of the x terms. Okay. They're only going to have the x squared terms that you can see. Okay. So these are very specific, but if you do this, then if you come encounter with one of these, they're actually really quite simple to solve. Okay, we're just going to have to use the idea that a square root, okay, the square root is the opposite of a square. Okay, so just like the opposite of adding is subtracting, the opposite of multiplying is dividing, the opposite of saying, of taking a square or something is taking the square root. Okay, and so that's what we're going to end up doing. So, steps one, when you come encounter with these, step one, you're going to have to isolate the x squared. Okay, so here on my example, isolating the x squared, meaning get everything else away from it. So I'm going to add 49 to both sides. Okay, so I have x squared equals 49. And then I need to take the square root of both sides. Okay, so I don't know if we've ever done this before. If you were in geometry, you have. But when you can take the square root of both sides of the equation, as long as you do it to both sides, you're okay. All right. And so what ends up happening now, one thing that you want to make sure is that when you take the square root, is that your number on that right hand side needs to be a positive number. 49 needs to be positive. Okay. It doesn't make sense if it would be a negative number. And that's because x times x will always end up being positive, right? Even if x is negative. 7 times 7 is 49, right? Also, negative 7 times negative 7 is 49. Okay. Either one, you're getting a positive 49. So make sure that that right hand side is always going to be positive. If you get an example where it might be negative, you would say that the equation has no real solutions. Okay. All right. But here we're okay. 49 is positive. So the square root of x squared, like I said, the square and the square root undo each other. So it's like they go away. So you're only left with x. And what are you going to be left with on this side? Well, the square root, normally what you would say is the square root gives you a positive number, okay? It gives you a positive number of what number times itself gives you 49. But here, since we're talking about an x that an x squared, there's nothing from stopping us from saying that x could also be negative 7. So when you take the square root of both sides, this is another important thing that you're going to have to do. You're going to have to take both the positive and the negative of the square root of 49. Okay, so I write plus or minus the square root of 49. So the positive is going to be 7, right? And then also x could be a negative 7. So remember how we used that notation the other day of plus or minus, okay? So x is going to have both squares, the positive and the negative, and that kind of reminds you that right there. It's kind of a weird thing, okay? But as long as you just remember that when you take the square root of both sides, you're going to take the positive and the negative, okay? All right, so let's go ahead and do some of the examples. Um, all right, so first thing, always isolate your variable, your x squared. So I'm going to add 16 to both sides. Okay, so I get x squared equals a positive 16. Good. All right, and then what we're going to do is we're going to take the square root of both sides. But what happens is that my x could possibly be negative as well. So what I'm going to do is I'm going to do both the positive and the negative of the square root of 16. Okay, so what am I left with? X equals, well, the square root of 16 is 4. So I'm left with either a positive or a negative 4. So here, X has two different answers. Okay, it's a positive 4 and a negative 4, which if you plug that into your equation, you see that it satisfies that equation. Okay, I'm gonna leave number 2 and 3 for you because those are pretty easy. Okay, so let's go ahead and do number 4. I had to subtract 7 from both sides. X squared equals, what is that gonna be? 81. All right, my x squared is isolated, so I could square root both sides, but I have to take the positive and the negative of that. So I have x squared equal, or sorry, not x squared anymore. They went away. X equals a positive or a negative 9. Okay. Number 5, let's isolate that x squared. So we add 5 to both sides. We get x squared equals 1. I take the square root of both sides. Okay, I got to consider the positive and the negative of the square root of 1. So the x squared, the square root of x squared goes away. So that's going to be x equals, what's the square root of 1? Just 1. 1 times 1 is 1, right? Okay, so let's do number 6. I need to isolate that x squared. So the first thing I want to do is divide by 6. Okay, so those go away. X squared equals 9. Then I'll take the square root of both sides, okay? And I get x equals plus or minus 3, okay? Plus or minus 3. So I'm gonna let you guys do this guy. Don't forget that when you're gonna divide that negative 2 away, you have to divide by negative 2. Okay, number 8. So the easiest way to get rid of a coefficient that's a fraction is going to be multiplying by the reciprocal. Okay, and so maybe you saw this in Algebra 1A, but to get rid of this 3/4, what I want to do is I'm going to multiply it by 4/3. The reciprocal is just switching the fraction. So, but if you multiply that side by 4/3, you also have to multiply this side by 4/3. Okay, so what happens is you end up with 12 divided by 12, which is just 1. So 1 times x squared is still x squared. Here, let's see, 48 times 4 and divided by 3. I'm going to do this division first because it's going to keep my numbers a lot smaller. 48 divided by 3 gives me 16, I think. So 48 divided by 3 gives me 16. And then multiply it by 4. Now, we do have some options here. We can keep this just as a multiplication problem, and I'm going to show you why here in a second. Let's take the square root of both sides. Okay, x squared, the square root of x squared is just x. And then I'm left with plus or minus. Now, if we remember, if you have a product inside of a square root, you get to take the square root of each factor of the product. So the square root of 16 is 4. And the square root of 4 is 2. Okay, so all I did was take that square root separately. The reason I waited was because then this number would be a lot bigger. And it's not that it's terribly hard, but they could end up getting a whole lot bigger, and it's a lot easier to take the square root of smaller numbers and then multiply at the end. So I get x equals plus or minus 8. Okay. All right. Let's move on. Okay. I am going to leave number 9 for you guys and number 10. Okay. Number 9 and number 10. So number 11, we'll subtract 66 on both sides. Okay. And so I get 7x squared equals a negative 63, okay? And then divide by 7. So I end up getting x squared equals a negative 9. This is a problem, guys, okay? This, when you have a variable being squared and you say it equals a negative number, that's impossible, okay? No matter what x is, it will never come out to, when you square it, it will never come out to be a negative number, right? If x is 3, 3 times 3 is 9, a positive 9. If x is negative 3, negative 3 times negative 3 is still a positive 9. So this equation does not make sense, okay? So there are no real solutions. Oops. All right, so there's no real solutions to 11. So be careful that if you, once you get the isolate the x squared, if you end up with a negative number, there is not going to be a real solution for that, okay? All right, let's do number 12. I'm going to subtract 3 from both sides. So I have 1/2 x squared equals 72. I'm going to multiply by the reciprocal to get rid of that fraction. Okay, so those go away. X squared equals 72 times 2 gives me 144. I'm going to take the square root of both sides, and that's good because 144 is positive. I end up with x equals a plus or minus 12. Okay, and so that list of square roots can also help you through this, okay? Let's move on. Okay, let's go ahead and skip the rest of these, okay? I'm not gonna make you do those, okay? Moving on to 17. Here, we're going to have numbers that are called irrational numbers. Irrational numbers are numbers that cannot be expressed as a fraction or a whole number. It's a decimal that goes on forever. And so any square root of a non-perfect square is irrational. And so let's look at some of these. So isolate the x squared. So I'm going to add 3 to both sides. So I get x squared equals a positive 3. Okay, and then let's square root each side. So I'll get x equals plus or minus the square root of 3. Now they wanted me to write my answer in the simplest form with a radical. Okay, so we did that in previous sections with simplifying, making sure that we know how to simplify underneath a radical. But on Alex, I will say that they tell you on these irrational ones to express it as a decimal. And so let's make sure that we're comfortable with how you would do that. Okay, so I just got a pretty basic calculator on my computer. Okay, and so I want to take the square root of 3. Oops, you got to hit the 3 first. Sorry. So 3. The square root of 3 is 1.73205 and so on. So if I want to say, let's say I want to round this to the nearest 100th place, okay? Let's see, what's the 100th place? Well, this is the ones place. This is the 10ths place. This is the 100th place. So I want to make sure that I have 3 digits. So what I do is I look at this guy. If this number right here is a 4 or below, the 3 stays the same. If it's a 5 or above, you have to knock the 3 up to a 4. But since it's a 2, my answer will equivalently be, see this little squiggly equal sign? Okay, this means approximately, I'm about to make an approximation, 1.73. Okay, and so since Alex on your homework is going to ask for the decimal form, what I'm going to do also here is always write the decimal form for us as well. Okay, So let's move on to the next one. I'm going to leave 18 for you guys. Oops. I'm going to leave number 18 for you guys. And then I'm going to do number 19. So I'll subtract 8 from both sides. So I get x squared equals 48. I'm going to take the square root of both sides, and I get x equals plus or minus, let's see what the square root of 48 is. Okay, so on here, I'll click 48 and then the square root, 6.92. And I need to know, should I round? I'm going to do to the nearest hundredth. Should this 2 go up to a 3 or should it stay at a 2? Well, since the 8 is higher than 4, we will round it up to a 3. So this will be plus or minus 6.93. We'll do the little squiggly lines there as well. Okay, I'm going to leave number 20 for you guys. And then I think that's just going to wrap it up. We'll skip number 21 through 24.